Good morning, everybody. So I'm going to give you an update on the new RV Tom Crean, which is a big investment by the state and Marine Institute in new research infrastructure. So I'm the Interim Director of Ocean Climate and Information Services in the Marine Institute. So just a recap on our existing national research fleet. So we have two vessels. One is the Celtic Hydra, which was launched in 1997, 31.5 meters long, can take up to 7 scientists and go to sea for about 10 days. And the Celtic Explorer then, which arrived in late 2002, which is a 65-meter long ocean-going vessel, can take up to 20 plus scientists, and it operates over 300 science days per annum. So you can see the sort of a typical year there, 2 crossings of the Atlantic, a lot of coverage in Irish, UK, French waters, and working in the North Sea and the Baltic. So why are we replacing the Celtic Hydra? Well, it's approaching 25 years of age by the time of replacement. We've covered over 460,000 miles since launch, and a lot of the major systems are approaching end of life. Marine science has evolved a lot since the vessel arrived as well, particularly Irish marine science, making the vessel unsuitable for many tasks due to the lack of station keeping and limitations on lifting capacity and deck space. The limited endurance can be an issue as well. And this year we had, this year and last year, particular challenges with COVID-19. We had to cut down to 2 scientists for a lot of surveys, just on the bunk cabin capacity. And we do experience some high levels of weather downtime due to the size of the vessel and what we ask of it, particularly in our far offshore. So the delivery of a new research vessel to replace the Voyager is part of the Marine Institute's strategic plan. It's identified as a key investment into the national research facilities in the NDP 2018 to 2027. It's going to help address some of the research challenges of Brexit and the common fisheries policy. It's going to assist in researching climate-induced impacts on our oceans and the further demands under the European Maritime Fund. So the project timeline. So we received confirmation of funding from DAFM in our parent department in 2018. We ran a procurement process and awarded a design tender to Skip Technis Design from Norway in January 2019. Got to work immediately, and we had a basic design completed by the middle of 2019. That helped us then issue a tender for the construction of the vessel in 2019. And then we began a detailed design process in July 2019, including looking at the energy efficiency aspects. There was a contract for vessel construction awarded to Astilleros Armon in Vigo in December 2019. And then equipment procurement and further detailed design work began then very early in the new year in 2020. Steel cutting commenced then in August 2020, and the keel was laid in November 2020, all on track despite the extreme challenges of the pandemic. The vessel is to be launched on the 1st of November, the 19th of November, this Friday in Vigo in 2021, and the vessel delivery is planned for Q3 2022. So we're delighted that the vessel is going to be floating finally on this Friday. So the outline initial design was for a diesel electric vessel with 2 generators, roughly 3 megawatts in capacity, burning ultra low sulfur marine gas oil, 52.8 meters in length. Vessel to be designed to meet the requirements of the ICES 209 curve for underwater radiated noise. Accommodation for 12 crew and 14 scientists, with an endurance of 21 days and capabilities in the areas of fisheries research, oceanography, hydrography, geology, ROV deployment, and buoy deployment and servicing. So the final design we ended up with, the length overall didn't change. The beam ended up at 14 meters, gross tonnage of just over 1,900 tons. It's classified by Lloyd's. It's got an ice class 1C, which is quite a relatively heavy ice class compared to the previous vessel. It's got DP1, up to 21 people. It's got Mitsubishi high-speed engines. It's got a separate harbour set. It's obviously one single electric motor driving a single propeller. It's a 7-bladed propeller to help with the silence of the vessel. It's got a 700 odd kilowatt bow thruster as well as a stern thruster. So in terms of the acoustic surveying equipment, it has two multi-beams at the moment. One dual RX 2040 on a retraction unit forward of the drop keel, with a second backup 2040 on the drop keel. And our experience from the Celtic Explorer is that having a multi-beam 9 meters down on a drop keel gives the ability to work in very high sea states. There's also provision for a more deep water EM 712 on the hull forward of the just forward of the 2040. There's a sub-bottom profiler, a Knudsen 3.5 and 12 kilohertz unit, which is hull mounted up here. And there's a fisheries echo sounder here on the drop keel with 5 frequencies. It's an EK80 system. There's a long-range fisheries sonar SU93, ADCP fitted here, a 45 kilohertz Pinnacle unit, and the ability to fit a 150 kilohertz in here as well. It's got a permanent Sonardyne Ranger 2 USBL on a retraction unit just aft of the drop keel, and it's also got net monitoring capabilities using Marport hydrophones in the drop keel. So in terms of oceanographic equipment, we have a 24 bottle CTD unit with 4,000 meters of wire on an active heat compensated winch from a dedicated launch and recovery unit. It's got the usual underway temperature, salinity, PCO2, and other water sampling in the bow, and also has a bow met mast for meteorological work. In terms of coring and sampling, it has an 8-ton T-frame on the starboard side, which can operate up to 4,000 meters of 14mm Dynex, which is ideal for piston and gravity coring, up to 12 meters in length, and box coring. It's also a hydrographic winch for day grabs and smaller sampling devices. There's an oceanographic winch then with 2,500 meters of coax, which is a multi-purpose for either towing oceanographic equipment, multi-nets, or side scan deployments. It has a 10-ton A-frame, which is set up for likes of vibrocoring, CPT work, and operating a camera sled. It also has a moving vessel profiler on the port gantry. You can just see a shot here of the wheelhouse up here, and there's a large coring winch over here, and some of our fisheries equipment here. So it's, we mentioned, it can take up to 14 scientists, equipped with the usual stuff, a gym, which is a big improvement on the Celtic Voyager. It's got good recreational areas. It's got a shore generator for fuel efficiency, all electric winches. It's a multi-purpose design as well, so we can take some items off the main deck as well when we're changing mode. So it has DP1, as I mentioned, using the bow and stern thrusters in the main screw, and it's fitted with an anti-roll system to operate in higher sea states. There's the general arrangement. So basically, on the lower deck, we have all the machinery, the diesel generators, electric motors, auxiliary equipment. Science cabins are on the tween deck here. It's 12 berths here. We have areas like the gym down here, trawl winches down below. Then we have a mess area, oceanographic lab, and we have our fish lab here. Some crew accommodation and messing and galley here. Mostly crew accommodation on the following floor, following deck, and 1 or 2 science cabins, and our operations center. Then there's a bridge trunk then that accommodates all the bridge electronics, air conditioning, and other items, and then followed by the bridge. And then we have a dedicated MMO station on top of the bridge as well. So the current status of the vessel, it's the hull was completed on the 20th of August. This is the current status here, so all the blue blocks are in position and finished and painted. So we're just waiting for the vessel to be launched and to come out of the build shed to have the final platform installed on top of the wheelhouse. So all items like doors, hatches, and windows are installed. All the transducers, sub-bottom profiler, multi-beam, and fisheries transducers are all installed. The frames and cranes are just in the process of being fitted when the vessel comes out of the shed. The wheelhouse was installed in mid-October. Fit out is continuing with piping, cabling, insulation, and paneling. I believe there's over 80 kilometers of cables going on the ship, so there's a fair bit of pulling of cables required. The hull was going to be launched this Friday. We've completed the first part of the dimensional survey for the subsea, the hull-mounted transducers, and then it will follow on with the upper part later on after launch. We will start commissioning systems, largely mechanical and ship systems, in February, followed by science systems, and then the science trials are planned for April-May 2020. Just a quick note on energy efficiency. We took part in the SEAI Exceed program, which is energy efficient design, and we held 2 challenge and analyze workshops with the vessel designers, and we amended the construction specs somewhat to reflect the output from the workshops. And then the final vessel construction tender had a few options to allow additional energy saving elements. We found that the marine sector was a lot more focused on hull efficiency and propulsive efficiency rather than hotel or on-vessel power use. And a lot of standard requirements of EU legislation, such as high efficiency motors, are not applied to the shipbuilding sector. So they're still using IE1 motors as opposed to onshore now it's IE4 and upwards. Our budget wasn't sufficient to make dramatic leaps into alternative fuels, and the vessel size is a limiting factor for many alternative fuel solutions. And then the big challenge is the infrastructure and access to alternative fuels in Ireland is a limiting factor. But we've incorporated several energy saving design options. We use this advanced silicon elastomer antifoul, which should last up to 10 years with an annual CO2 reduction of 107 tonnes. And we have a 400 kilowatt harbour generator for import or at anchor use, and that should save up to 45 tonnes of CO2 compared to running over the main gensets. And the vessel is designed to use shore power where available, so we can actually use grid electricity when we're in port. So that's a 300 kilowatt connection. So we should be able to use renewable energy when we're in port, but we just need to get the ports to provide somewhere for us to plug into. So we did look at alternative fuels. Basically, LNG wasn't feasible due to the lack of refueling infrastructure in Ireland, and also the size of the vessel and the requirement for the high pressure tank and the budget, of course. But you can, they say, reduce up to 25% CO2 with LNG. The jury is out somewhat on that, with methane slip being another factor. Methanol or hydrogen, basically the technology wasn't at a required state of readiness. That's changing now all the time. We looked at hybrid solutions, but the vessel needs an endurance of about 21 days. So it greatly limits the usefulness of a hybrid, other than doing peak shaving to avoid starting a genset. We've looked at hydrotreated vegetable oil, or HVO. So this fuel can be used as a direct drop-in to replace marine gas oil. So the vessel's fuel tanks and fuel systems and main engines are compatible. And there is more of this coming on stream. So this may be the optimal solution for at least the early part of the vessel's life. And the yard built a previous vessel for Sweden, the RV Svea, and it's currently running a 100% hydrotreated vegetable oil. So just other clean ship measures. The vessel being built to IMO Tier 3 limits in terms of emissions. We're using all biodegradable lubricants. The vessel will have a ballast water treatment system compliant with MARPOL, and we just made one side of the vessel for clean water intakes for science and the port side for discharges. The vessel will be extremely silent with its 7-bladed, very large propeller. So here's the projected noise performance of the vessel. So here are the latest pictures. So the vessel is currently still in the build shed. It takes half to the water at the moment at high tide. It's raring to go actually. Here's our 7-bladed prop. Here's our sub-bottom profiler with our 12 kilohertz and 3.5 kilohertz transducers, a multi-beam behind, and then the drop keel behind that. So you can see that the anti-foul that has been applied. Here's the EM 2014 or traction unit being surveyed in by the surveyor. And you can see the 7-bladed prop again with the vessel ready to go there. So it will be launched back into the water here on Friday. It doesn't have a bulbous bow to increase the acoustic performance. So it actually has we'd say a large volume bow to give you the buoyancy that a bulbous bow would give you, would not create the bubbles, which can have an adverse effect on the acoustic transducers. Here's just some more pictures of the interior. That's the fish lab. Here's a very small amount of the cabling that's going in. Here's a view from the upper port gantry. You can see down onto the main deck here. There's a fairly wide side deck. Very good line of sight from the bridge for coring and other operations. There's our winch with 4,000 meters of Dynex for the deep water work. So that's it in the yard there now. That's the CTG doors here. Yeah, so that's the progress at the moment. Another view looking down on the deck. All the winches are electric, provided by Ibercisa, a company from Vigo. And that's it.